solar system may be a cosmic misfit, say Astroboffins, who've analyzed systems where we've spotted exoplanets. A team of astrophysicists suggested we live in a weird neighborhood after analyzing the radius and semi-major axis of 909 planets in 355 multi-planet systems spied by the W.M. Keck Observatory in Hawaii. The results of the survey have been published in the Astrophysical Journal. They found the planets in the same planetary system have correlated sizes. Each planet is more likely to be the size of its neighbor than a size drawn at random from the distribution of observed planet sizes, the paper said. If the system contains 3 or more planets, the planets are also more likely to be spaced regularly. Smaller planets seem to sit closer together than larger planets, leading scientists to believe that the patterns developed early during their formation. Lauren Weiss, lead author of the paper and a postdoctoral fellow at the University of Montreal, said, "The planets in a system tend to be the same size and regularly spaced, like peas in a pod. These patterns would not occur if the planet sizes or spacings were drawn at random. This is at odds with our solar system," Weiss explained to the Register. Unlike these exoplanetary systems, the solar system has incredible size diversity. Earth is more than twice the radius of Mercury, Neptune is 4 times the radius of Earth, and Jupiter is 10 times the radius of Earth. Also, the terrestrial planets are very widely spaced. The authors suggested the complex gravitational interactions between Jupiter and Saturn are to blame. When the terrestrial planets were still forming, Jupiter and Saturn scattered the protoplanets and increased the number of collisions among them. This disrupted the planet formation process, preventing any regular patterns in size and spacing from forming. It could mean that other planetary systems went through a less violent formation process compared to the solar system. The researchers hope that their discovery will help scientists better understand the origins of planetary systems. The results can also be used to make predictions about other additional planets in future exoplanet discoveries and may even help us find potential habitable worlds, Weiss explained. If we find one potentially rocky exoplanet that's too hot to be habitable, it might be worthwhile to search for additional planets in that system, because there might be a similarly sized planet in the habitable zone waiting to be discovered. If we are trying to find life on a world like ours, first we need to find other worlds like Earth. We want to find worlds that have rockier watery surfaces with thin atmospheres. If the atmospheres are too thick, light does not penetrate them, and so even if there is life deep down we probably won't be able to see it. The worlds that could have thin atmospheres are smaller than about 1.5 times the size of Earth. So we are looking for small planets about 1.5 times the size of Earth at temperatures where liquid water can exist, which is important for the chemistry of life as we know it, she told Registered science-sponsored Minds Mastering Machines call for papers now open.